Okay, so hi guys, let's continue our discussion for our quarter 3 lessons in geometry. This time we are on similar triangles. Okay, so for our 5th lesson on similar triangles, so that's the AAA, SSS, and SAS triangle similarity theorems. Let's try this problem. Okay, so in the diagram below, is area of triangle ABC greater than the area of triangle XYZ? So based on the figure, they kind of look just the same or are similar to each other. But if we have givens, okay, given information or evidence about these two triangles, so that would vastly differ. Okay, so let's try to analyze the first given. We have AB is equal to 4 and XZ is equal to 5. Now, those are good values as givens, but on their own, they won't stand or they won't really build a good argument. So that's why for number 1, if we're only going to use number 1 as our evidence, it would be insufficient. Okay? And if we're only going to use the second one as well, so it says here that AC over BC is equal to XY all over ZY. Okay, so the arguments themselves are good, but if they're just gonna stand on their own without interacting with the first argument, therefore this would be insufficient evidence as well on themselves. But if we try to combine these two evidences or these two information that we have, therefore we can build a solid argument that might prove that the area of this first triangle is greater than the area of the second triangle. Okay, so let's try to write that down. Okay, so for the first one, we were given that AB is equal to 4 and XC is equal to 5. Now, according to this problem over here, to the second one, we have here that AC over BC is equal to XY over ZY. Now, both BC and ZY are hypotenuse of these triangles, and AC and XY are side measurements on the same triangles. Now, since they are both right triangles, they can be similar to each other. They are similar to each other. So we can say that triangle ACB is similar to triangle XYACB XZY. Okay, so they're similar to each other. Okay, now since we know that they are similar, since we know that these two triangles are similar, the second statement that we could say about them is that their areas should be proportional to each other. We can say that the area of triangle ABC should be proportional to the area of triangle XYZ. I'm sorry, XZY. Okay, yeah, I keep interchanging the triangle ABC and triangle XAY. Now, there is an included side for triangle ABC, and that's AB. That's equal to 4. And the included side on triangle XZY is, okay, so that would be 5. Okay, and since we're solving for areas, we can square these two sides to get a value of 16 over 25. Now, according to the rules for, or the theorem for finding the proportion of the area of two triangles, so both of them, okay, so the ratio of these two areas must be greater than 1, okay, in order for us to say that the area of ABC is greater than XYZ. But it turns out that the ratio of these two triangles, with ABC being the first triangle and XZY being the second triangle, turns out that 16 over 25 is less than 1. Okay, so therefore, no, it cannot be said that triangle ABC has a greater area of XYZ. So the answer here is no. It cannot be said that triangle ABC has a greater area than triangle XYZ, or XZY for this matter. Okay, and that's how we solve this problem.